What's going on, everybody, and welcome to a tutorial on Correlation 1's game of Terminal, which is a competition where you compete against other players. It's kind of a game map like other games you might have seen, like Halide or something like that, although this is a fixed game map. But the idea is you compete against other players at writing these bots in various languages. We'll, of course, be using Python. So Correlation 1 is just a company that aims to help other companies find data scientists by way of having challenges like this, really not much different than like Kaggle or like 2 Sigma's Halide, for example. So I think the best way to learn Terminal is likely just go play it by hand a couple of times, or you can follow along with this tutorial and hopefully learn it. But before we get too far into a tutorial, I would just want to describe the actual unit types, because that's pretty useful to understand what you have. So it kind of falls under, the unit types fall under 2 different categories. You've got attackers and defenders. So under attackers, you've got ping, EMP, and scrambler. The ping is a very, very cheap unit, but also it doesn't really do much other than it's really fast, but it's weak, so it'll get destroyed quite quickly. You've got the EMP, which is a lot slower, but it's quite powerful. And then you've got a scrambler, which also affects other enemy information units as well. Then you've got your defenders. You've got a filter. The filter, again, is cheap, can't disrupt any enemy units, but it can kind of get in the way, create a wall, basically. Also, you can use it to protect your other larger defender units. So you've got now you've got a destructor. This is quite expensive, your biggest one, but it can also destroy other enemy units. And then finally, you've got the encryptor, which just strengthens your offensive units or your information units. Okay, so basically you can read more. There are tons of rules and just documentation in general as far as how things actually work, because all you do is you place and you start your enemy units, like you deploy at a location, and that's it. So the rest, like all the movement and stuff, is just completely automated. So it'd be wise probably to go read the documentation to get an idea for exactly how each thing is allowed to move and like what happens in certain scenarios. So really it's more about coming up with a strategy and placing units, kind of like a game of chess or something like that, rather than a game like Halide, where actually your biggest thing is like, how do you want to move? This is more of how do you want to place units. So with that, let's go ahead and get started. There's 2 kind of major ways you could do this. You could either code locally and then upload your algorithm and then see how things went. But generally, I think to develop, you want to be able to see like what errors you might have made and stuff like that. And so if you just upload, it's a little challenging, but it can also be challenging to run it locally, especially on like Windows. But if you go to their GitHub, I will put links in the description for all this stuff. You can get the install. Basically, you're going to need Python 3.6 or later. You're going to need PowerShell, which comes with Windows 10. Otherwise, you can install it. You also will need Java 10 or later. And then you need the starting script. I've already done all the things that I need to do, but again, definitely go to their the GitHub. Again, I will link to the GitHub in the description for sure. Also, I'll have a text-based version of the tutorial so you can get all the info. But probably the hardest thing is just making sure this part works. It can be a little finicky with PowerShell, and also I'm just not that great at PowerShell. This was actually the first time I've ever made use of PowerShell. But like I said, you actually don't have to use PowerShell. Also, if you're on like Mac or Linux, you'll be fine just in your terminal. It's really just if you want to run on Windows. But it is super useful to be able to develop locally so you can actually see what errors you hit. So anyway, the next thing I'm going to do is clone this. I'll download the zip and we'll get started. Also in Terminal, I'm already logged in, but you can log in with your GitHub basically. So I'm going to move this over. I was hoping to stick it to the side of the screen. For some reason that's not working. Okay, so I think what I'll do, I think I'm going to leave that up. So I'm just going to extract this. Great. And if you are on Windows or any other operating system, for example, and you just don't have Java or whatever, feel free to pause the video, get the things that you need to actually run, and then come back. Wow, this is taking a while to extract. I didn't think that was going to take so long. So once we have that, let's go into this directory here. And then into the master here. And just for the record, to like run things, you can just type PowerShell, again, if you're on Windows, to get that to pop up here. Cool. So now for just a quick example of like running things, this will be the way that you run pretty much everything. Also, make sure if you do type Python that corresponds to Python 3.6 or greater. Okay, so the next thing is like to run something, I would type like Python, and then we want to run scripts, and then it's run_match.py, and part of me wants to shorten this so it doesn't take up the entire screen, but it's okay. I'll just do maybe this. Anyway, we want to use runmatch.py and then the two things that we want to run. So in this case, we're just going to run this sample algorithm here. So it'll be Python algo. So then you just say Python algo versus Python algo, hit enter, and make sure that works. If that doesn't work for whatever reason, feel free to come into like our Discord, discord.gg/Centex, and feel free to ask questions. Also check out, like I said, the correlation one GitHub. And all that, and because like I said, on Windows it can be a little finicky, especially with running various different things and permissions issues and stuff like that. So just take note of that. Okay, so anyways, this appears to be running just fine. Whenever it is done, we'll get a replay in this replays directory. Looks like we've got one building right now. And then once you have the replay, you can come into the terminal website and then go to play, and then right here you can drag and drop a replay file. But first we're just going to get coding and then worry about the replays. But also in here you can play like by hand and then versus a bot or something like that, or by hand versus by hand. It's kind of a good way to figure out a strategy to play. Or you can play like by hand versus one of your bots and stuff like that. It's pretty cool. So minimize this, and in fact what we could do, I could just upload that since that's done now. So you would just click and drag that over to your replay file here, hit watch replay, maybe, pretty sure I clicked it. I don't know, this machine is going kind of slow today. There we go. I'll start the tutorial, or start the replay rather. Okay, so as you can see, and then you can kind of you can speed it up by coming down here, and then I can go like 8x speed. Anyways, so these are like the defensive units, and then this is like an attacker unit, and the goal is to get to the opponent's edge, and that's kind of how you get points or get rid of enemy health, stuff like that. So now I'm going to minimize this. And I guess I'll leave this up for now. We'll come into here, and I am going to make a new directory, and we're going to call this tutorial algo. And then we're going to take some of the files from the Python algo here. Cool. We'll take gamelib run. This is a PowerShell script, by the way. Algo JSON, and I'm going to copy the algo strategy as well. We're probably just going to empty it, but that's okay. And then we'll come into, where's the one I just made? Tutorial algo. I need to zoom in. I can't even see it. There we go. Cool. Okay, now the only thing we need to modify here is algo strategy, and I'm going to use Sublime Text. You can use whatever you want to use. Open with Sublime Text. Cool. All right, I'm going to empty that out. Start nice and fresh. All right, so now what we're going to do is begin to build our algo. First, I'm going to import gamelib. This just has a lot of the helper kind of functions and stuff for interacting with the game for us. Then class tutorial bot. And then in here, we will inherit from gamelib.algo core. So then we have define on game start. This just is run one time. This is where you're going to set any of your your kind of constant values or variables that you want to use throughout. self.config equals the configuration that's passed. For now, we're not going to set anything, but pretty quickly we'll set like our units there, because the library of the units that we can choose from, basically, it is not going to change. So that's like something that you would set here, any sort of like constant value. Then what we're going to say is define on turn self and turn state. And for now, we'll just pass here. And then finally, to run, if name equals main, algo equals tutorial bot, and then algo.start. So that's just kind of like a quick initial skeleton of how things are going to work. And then basically so here you'll define all your starting values or whatever. Then on turn, this is where your logic will go. Now, this doesn't do anything, so let's go ahead and do some stuff. First, we'll set some of these starting values. So we're going to global a bunch of stuff here. Filter, encryptor, destructor, ping, EMP, scrambler, unit to ID. So we're going to global all of those. We're actually not going to set unit to ID here. So we'll take this. Let me zoom out a little bit. Cool. And then we're going to say filter, encryptor, destructor, ping, EMP, scrambler equals, and then we're just going to do a quick list comprehension here. This will be equal to the config or self.config unit information, and then we'll use index, and then shorthand for IDX in range 6. So that's just going to iterate over these unit types, basically, so we can save those. So when later we can just reference filter, encryptor, destructor, and so on as the thing that we want to build, right? So those are just our unit types. Would be nice if these were just like stored in some way that we could just import them. I think that would make a little more sense, but this is the way that I'm going to do it for now. So now that we've done that, we're ready to actually do something on turn. So first we're going to get the game state, because that's going to change every single time. So game lib.game state self.config and turn state. So that just tells us what the state of the game is, so we can get certain values of where things are placed and all of that. Then what we're going to do is game state dot enable warnings equals false. So right now it seems to be, I don't know, some sort of a bug where you get like this warning every single time. So I'm just going to turn that off. If something's happening, you'll still get certain errors and stuff just fine. And if for whatever reason something's happening and we can't figure it out, we can set this back to true. But we end up getting this like could not spawn at location over and over and over, even when like that's not an issue. So we're going to set that to false for now. Then on turn, basically, we've got two different types of units that are doing two different types of things. So we're going to basically have two methods, one for attacking, one for defending. So we're going to say self.defense, and this will take in a game state for now, and then self.attack, also game state, and then game state.submit turn, and we should be good to go. So then, obviously we need to have these methods actually exist. So real quickly, we'll just add those. So define defense, self game state. For now, we'll hit a pass here, and then define attack self game state. Game saute game state, and we'll pass again. So the logic for defending will go here, and the logic for attacking will go there. Okay, so now we will start with our defense logic. So what we're going to do here is basically, I think what we'll have a quick helper here. So define build defenses. And what this will do is build defenses if we can, otherwise kind of notify us if something went wrong, basically. So self location list, firewall unit, game state, and row equals none. So these are kind of like coordinates, or you can pass row here. So you would have like a row and then an X location. So row is almost interchangeable with Y. So it's basically, like where do you want to place a unit? So again, pretty much the entire game is all about whether it's a defensive unit or an attacking unit. It's where do you deploy that unit? That's all you have to think about in this game. So, or at least that's the only action you get to take. You obviously need to think about a little more than that. Probably take into account some of your enemy positions, stuff like that. Okay, so then what we'll do is zoom out some more as we continue to have too long of lines. For location in the location list that we pass, if not type location list, then we're going to say location equals a list that is location X, and then what row do you want to be on, Y. So then that basically is going to populate the things for in terms of like where we want to place units. And then what we want to say is if game state dot can spawn a firewall unit at that location. So reasons why you wouldn't be able to spawn something, maybe something's already in that spot or something is passing through and so on. So anyway, also, can we afford to actually spawn it? So anyway, game state can spawn. Okay, so what we'll say is game state dot, oops, don't want to capitalize that. Game state attempt to spawn a firewall unit at that location. And then we'll use debugging gamelib.debug underscore right f strings firewall unit deployed at location. Then, we will decrease that resource. So game state dot player underscore resources 0 cores minus equals game state dot type underscore cost firewall unit. So if we've spawned one of those, what we want to say, or basically we want to take away the cost from our resources, so we know later on can we spawn, for example. Okay, so once we've done that, make some space here. So if we can spawn, great, we will do that. But if not, game state dot contains stationary as soon as I can figure out how to spell stationary unit at that location, we will return false. So if there's some other reason, like so if we try to spawn that unit, but there's already a unit there, that's okay. We haven't like run out of resources, for example, but for any other reason, we want to return false and we're done iterating here. Otherwise, if we make it all the way through, return true. All right. So now what we want to do is create, basically, this is what we'll pass lists, and then we'll pass a type of unit here. And that, so like our build defenses, all it's going to do is build defenses for basically the locations and the type of unit that we pass. So now coming back to our defensive or our defense method here, now we want to populate with locations. So again, the game is a fixed size, this grid right here, every single time. So everything's in the same spot. So at least to start, the best way I can think of to do it is just by manually figuring out. It's like if you hover over here, you can see here, I'm pointing to it, but they're over here. Anyway, you can see where the positions are, and so that's probably the way I think most people are doing it. Eventually it'd be cool to somehow to algorithmically pick those locations, but for now we're just going to hard code them because there's really no reason not to, other than later you might want to algorithmically choose it based on maybe where your enemy is deploying units, something like that. Anyways, for now we're just going to hard code the positions. So defense, basically we're going to say, okay, where do we want our filters to be placed? And so we're going to place those, and this will just be a list of lists. So we're going to place those at 0, 13, then 27, 13. So that's basically the edge on one side, edge of another side. Then 1, 12, and 26, 12. Then what we're going to say is we're basically going to pass those to our function here, and then make sure that we didn't hit a false at any point along the way. So what we're going to say is if not self.build defenses, and we're going to pass filters as the things, basically the locations. Filter is the unit we want to use, and then game state is the game state. Cool, successful, if not. Then we want to build our destructors, and all the destructors are going to be on the same row. So we're going to say the row is 11, and then we're going to say destructors. Their X position will be a 2, 25, 6, 21, 11, and 16. Again, to pick those, I would just recommend going and hovering over that map to figure out, okay, here are the positions that I want to use for now. And later on, you can get a lot more complicated than that, but I think to start, that's honestly just the easiest way to do it. So now, if not self.build defenses, and this time it's destructors, then destructor, and then game state and row equals row in this case. Return. Okay. So now we've got that, and then we could build even more filters after this. Like you would pretty much want to continue populating until you've run out of resources, pretty much. So now I'm going to pass filters, and this one is going to be 3, 24, 4, 23, 5, 22, 7, 20, 8, 19, 9, 18, 10, 17, 12, 15. And again, this will basically happen in the order that you pass. So keep in mind that it's like you might get a unit to here, here, and here, and then you've run out, right? And you can't produce any more units. So you'd want to keep in mind that these are in order of importance. So you've got filters, and then if not self.build defenses. And in fact, we'll just do this. Copy that. Paste there. Done. Okay, so let's save that and now come over to our PowerShell. I'm just going to hit the up arrow here, and rather than Python algo, I think what do we call it? Tutorial algo versus Python algo. That's fine. We'll run that, make sure we just don't end abruptly. Okay, it looks like we ended abruptly. Let me scroll up here. Okay, game state not defined, so I capitalized the S in game state somewhere. Yay. Find where I did. Oh, I actually see this one at least. Let's save that. Let's run that again. It's totally possible I made that mistake multiple times. Also, could I, while we wait on that, font. Looks like I hit another error. Let's try 36 for now. Ooh, that's quite large. Okay, our issue here, I forgot to add the row here, right? So up here, we were passing that as part of the location, but what we need to pass here, since we're gonna send them all to the same row. Save that, run that, And then now what we should get is an actual replay. While I let that go ahead and play, I am going to come over to the algorithm itself, and we'll package that up and also upload it. So let me do this. Python algo. We actually want tutorial algo, so all you need to do is just zip it up. So I'm going to right click, send to desktop. We'll leave it named the same, no problem. And then you can come to play, and or actually, let's go to my algos. I thought we could upload it and play. Yeah, come here, come to one of your empty spots. And actually, that other bot is the same thing, but let's make sure it works. So we'll go to desktop, come into here, and we'll grab that zip that we just made. Open. Okay, and that'll bring it in. That'll compile for a little bit. Looks like it's almost looks like it's done. Looks like it compiled pretty darn quickly. And then eventually you'll start seeing some games here. Ooh, we've actually made some wins. But as you get games up here, you can hit play and all that. I'm kind of curious how we won without attacking anybody. But okay, that's fine. So we can play this one, for example. Wait for it. Press here. I wish it would just start automatically. And then we'll speed it up. So as we can see here, we've got our side here, and then as the turns progress, we start adding more of our defenses in here as we can. Eventually, we are definitely going to lose this game, but soon we'll start adding our own attackers and hopefully doing a little better. But I think right now is a decent stopping point. So in the next tutorial, we will add some attacking, and I think we'll do much better. I think we'll rank a lot better for sure. If you've got questions, comments, concerns, whatever, feel free to leave those below. Also, if you want, you can compete in a Centex only competition at c1games.com/Centex. You can come there. There is a $500 cash prize for the competition, and if enough players come in, they'll raise it to 1,000. So we'll see how that goes. Otherwise, I will see you guys in the next video, where hopefully we do a little more than defend ourselves. But as you can see, our defenses are working good enough. So anyway, questions, comments, concerns, whatever, feel free to leave them below. Come chat in Discord, especially if you're having any issues, all that. That's discord.gg/Centex. Otherwise, I'll see you next time.